Hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. So today is day 12 of the 20 days of the statistics, and today we want to discuss about the t distribution and the tree distribution, that is the small sample inference. Okay, so in our previous video about where we discuss about the central limit theorem, we discussed that when sample sizes are large, the central limit theorem ensures that the sample means approximate a normal distribution. But what about if the sample sizes are small? That is, if our n is less than 30. N is less than 30, because greater than 30 is handled by the central limit theorem. But what if our n is less than 30, or when population variance is unknown, the normal distribution isn't reliable? So that's where the t distribution and the chi distribution come in. So let's talk about the t distribution first. Okay, let's talk about the t distribution. So the use case of the t distribution, I must say, would be like estimating the population mean when the sample size is small and when the population variance is unknown. Okay, we use the t distribution when the sample size is small and when the population variance is unknown. Okay, so talking about the shape of the t distribution is similar to the normal distribution, but with heavier tails, like the more probability in the extremes. Talking about the shape, it is same as normal distribution. Okay, but with heavier tails, of course. Now, talking about the degree of freedom. So, it is defined as n minus 1 for a sample of size n, and as the df increases, the t distribution approaches the normal distribution. Talking about the applications of a t distribution. So, of course, its first application would be one sample t test, in which you compare the sample mean to the hypothesis population mean. In this, we compare sample to hypothesized population mean. And the second application is the two sample t-test. The two sample t-test, in this we compare the means of two groups, that is the independent or the paired. Compare mean of two groups. And these two groups can be independent or paired. Now, talking about the chi-square distribution. Chi-square distribution. So the use case would be testing the hypothesis about the variance and testing the independence of the categorical variables, also the goodness of fit test. Okay, talking about the use case, in this we test the hypothesis about the variance. Hypothesis about variance and testing the independence of the categorical variables. Testing independence of categorical variables. Okay, so in talking about the shape of a chi distribution is skewed towards right. Okay, so talking about the shape is right skewed, and especially for the small df, it becomes more symmetric as the df increases. It becomes more symmetric as the df increases. It becomes more symmetric as our df increases. Now, talking about the degree of freedom in the chi square distribution depends on the number of categories or the constraints in the test. Talking about its applications, it is used for the chi square test for the independence and the chi square test of good of fit. It is used in the chi square test for independence. For example, are gender and product preferences different? And another example is this used for testing the chi square test of the goodness of fit. For example, does observed dice roll data fit a uniform distribution? So, talking about mainly the differences of this is that t distribution is the mean inference, that is a small samples, while the chi distribution is about the variance, independence, and the goodness of fit. The shape of the t distribution is symmetric, bell shaped, heavier tails, while the chi distribution is right skewed and becomes symmetric with the large degree of freedom. The degree of freedom in the t distribution is n minus 1, while the chi square distribution, it is like categories minus 1. Common test is like in the t distribution, it's one sample t test and two sample t test, and the t distribution, it is like independence test and the goodness of fit variance test. So approaches like as df increases to infinity, and in chi distribution approach is normal for the large df. Talking about in the data science context, the t test helps in comparing the model performance metric across the small validation sets that we perform, while the chi square tests are widely used in the feature selection, that is the checking the independence between the categorical features and the target variables. So both this distribution allows us to make the valid preference under the uncertainty when the data is limited. So if you like the content of this video, just like this video, subscribe my channel, and do not forget to hype my video so that I stay motivated, and meet you in the next lecture of the 20 days of the statistics course. Till then, bye bye.